So let's take a look at deep learning landscape. The domain is very important. The resources are too many. The field is very fast moving. So in order to make sense of this chaotic and highly important field, we first need to know the landscape so that we understand the thing better, right? So think of deep learning as a big domain, which itself is one part of ways of doing intelligence. There is machine learning, there is deep learning, and there is reinforcement learning. So if you want to become a master in artificial intelligence, then deep learning will be just one of the steps towards it. But need to know that it is a one step of three different ways. So now looking inside deep learning, it is made up of two parts. Okay, two domains. Primarily these two. There are also other domains like audio processing, then video processing, but primarily computer vision and natural language, which is the language we speak, understand. It could be any language, English, Hindi, Marathi, Russian, Ukrainian, anything. That is natural language processing domain. Okay, internet is full of mostly text data when it began. Now it is full of images and videos. So the computer vision data has grown more recently, and text data has always been in use since inception of internet. So these two are the domains. Now, as the name itself says, they both of them are part of this neural network, and both of them use deep neural networks. Okay, and their use case is very informed by that name, right? So when we see as a human eye, when we see a crouching tiger about to jump, we know that it threatens our survival. We know it's an animal who is a predator. We know a lot more things at that time, and we act accordingly. We take a decision to improve our survival in a split second, less than zero point 0.1 seconds. This whole thing has happened. The data where the tiger is about to jump, it went to our eye. From there, it was transferred via optical nerve. It went to a part which is called as LGN. It forwarded that data. So this data is in format of electrical impulses. Okay, it forwarded the data and it was subsequently processed, and then we recognized it as a tiger, and then from that we associated that with other information, and then everything happened in zero point 0.1 seconds. That is computer vision. Data of images being processed by the network, in our case it's our brain. Then we have natural language processing. So if the same thing is passed as a notice, or it is announced on an audio speaker, which is please evacuate, there is a tiger on loose in the area. Okay, exact same thing we would do, but to achieve the same thing, it was a different path. Here we had to understand image on the left hand side. On the right hand side, we had to understand the meaning of the words. Okay, we take images also for very much granted. We take, oh, tiger. I mean, I have easily recognized it as a tiger. We take that for granted, but in reality, it is a very complex task. Similarly, ability to make sense of the words, we take that for granted. But there is a lot of meaning in words, and it is that is what we are understanding when we read or listen to anything. So we understand what is the most important word here. We understand there is tiger is the most important word. It is loose, and then we should evacuate. So you see three things. Then we also understand what is a tiger. It's a predator. So as you can see, it's all one-to-one mapping. Okay. Just the path is through meaning of the word, semantic meaning of the word. Okay. And the neural networks are used for two different purposes on two different kinds of data. But the thing they are learning, it's actually quite similar. So here, that's why computer vision as a domain and languages as a domain, they're merging now. Okay. So this is how the division is. Now, if we move to artificial vision, yeah, or artificial language aspect, where we are using our AI to process them, it will be a single image. an image of a crouching tiger about to jump, or it will be a text in which it has 1, 2, 3, 4, 5, 6, 7, and 10 or 12 words. One word is please, the next word is evacuate. So it's a simple text file. Okay. So it is data on our laptop or on a pen drive or internet or anywhere, and we process them by using a program we have written. And if it can do what we can do, then we have achieved artificial intelligence for domain of vision and language artificially. Plain, pretty simple. Okay. So, but even though they both are doing quite same thing here, the modality is very different. Okay, we say we take vision for very granted, but we don't realize how complex vision is. Okay, if you simply Google bandwidth of human senses, okay, let me just Google it and here. So bandwidth of sight is same as almost 1 GB per second, 1 GB data per second. That's the amount of data which is being read. Now we need to process, and after processing that huge data, we need to make sense of it. Tiger as an image, which is like huge, watching a movie takes a lot of consumes a lot of our data. So we understand, but whereas if it was text, if it was language, then it is very low in terms of its bandwidth. So you see, image would be 10 megabytes, a single image, whereas a sentence might be just 100 bytes or something. So you see, in it even though they both are doing the same thing, the amount of data and the complexity between the data is very different. They say image is worth more than 10,000 words. But here, if you take a look at this image, it is only saying details about what is present in the image. Whereas when we combine a lot of words together, it's when their power starts becoming apparent. 1 MB is just maybe a picture in computer vision, 1 second clip in video processing, and in natural language processing, it's worth one book. 1 GB data. You have again 200 images or just 10 minutes video or an hour video, maybe, and you have 500 books. Now this much is enough to store entire knowledge probably until graduation of most fields right now. So you see 500 books which are in 1 GB, it is enough to contain the entire knowledge of humanity. So as a value, it actually is quite high. So even though image is worth 1,000 words, powerful words together, they are worth a lot more. Imagine value of calculus, right? So image as a natural image as an image holds details of the objects it has or maybe patterns between them, whereas natural language power is multiplied by the concept also which they're representing. I mean, it could be a trashy romance book, or it could be a calculus, or it could be completely a new domain which is invented by someone, right? So for 1 TB data, just 200,000 images, or maybe 1,000 movies. But in books, it probably is huge knowledge. Okay. So these things leads to differences between in these four main dimensions. In computer vision, we have huge data. In the current world, because of our smartphones, one advantage of this large volume is there is a lot more data to learn from. Its disadvantage is it is costly to store, slow to access. So it's all large volume kind of like considers all of them. And whereas in natural language processing, it has a lower volume comparatively, but the information is dense. And also the nature of data, it's not as duplicate as we have in computer vision, because I think internet is mostly full of cats, some videos, memes, and random stuff, right, in terms of images. So anyways, so then in the concept of the network itself, because we can understand something which if we see immediately, for example, this is the brain in front of me, brain model, we can understand it immediately. Okay, this is brain. uh, but if I were to ask inside my brain, where is brain, what is brain saved as, actually as a concept, what is the meaning of the brain. Now internally it's something, okay, and if we ask the same question to a neural network, it is something random which we can't understand. But we ask, show me what you have learned, we can easily see and understand the image. So comparatively, computer vision neural networks are easier to understand. Even though they have to operate and process huge volume of data, they're easier to understand. Okay. Whereas natural language processing, even though they train quickly, they're lighter, the data volume is lower, so effectively it's better. They're harder to understand because the meaning of the word is shown as a simple integers, not integers, floating point values. Okay, it is a vector of floating point values, and we can't just make sense of that. So, then another consequence, it was quite apparent when I was talking about data. The computer vision models are slower and harder to train, whereas natural language processing ones are easier to train. Similarly, the models of NLP are smaller and computer vision are bigger. So the computer vision as a domain is more hardware architecture dependent, and we also have to collect huge data here, whereas NLP doesn't have the limitations in those dimensions. So you see, these domains division is quite important because it kind of like completely informs, the approach and what we should learn first, what we should learn later. Because you see, in any book or any course or anything you will go, you will find computer vision is taught first, NLP is taught later. Why? Because it has a lot of things. Despite being large data, despite being this thing, it's kind of like easier to understand and we can conceptualize and visualize it better. So it is better to get started with that. And once we build our expertise, only then we move to the next part. So this landscape kind of like informs our learning, which kind of like helps us make sense of the chaotic learning resources. We all have, it's like too many blogs we have, too many learning resources we have. If I kind of like just show you my Notion thing where I simply track all my learning resources, you'll think it's crazy. So these are different courses. So from here to here, each and every row is something. It's either a course or a YouTube series or a research paper or a book. And there are more than 34. And I don't think I've included, maybe half of the stuff I think I need to know to be a SME. So you see, there are too many courses and it's hard to organize, especially if you're a beginner. Okay. If you are getting started in a domain, where to get started from is the hardest thing. Okay, what to get started from, the previous section answered. It's better to start with vision. But how do we kind of like distinguish between everything which is present in that whole domain? Okay, so that's where this landscape will actually help you. So one thing to kind of like know is no knowledge appears randomly. So for example, Isaac Newton. I don't know if you know Newton. He's one of most amazing scientist ever. Okay, and he invented calculus. Calculus is a domain of mathematics which kind of like allows us to study rate of change. And now, why is it so important? Because everything changes, right? The only thing constant in the world is change, they say in the motivation quotes, right? So using calculus we can quantify change, we can see dependencies between A and B. When A changes, how does it impact B, C, D, E, F? So calculus allows you to understand from molecules to universal scale. So his innovations were amazing in scale. And even he said that if I have seen further, it is by standing on the shoulders of the giants, existing giants. So knowledge is built on top of old things. So if we want to go to the next advanced level directly, it's actually not directly possible. We need to build our foundation. Okay. So similarly, if we take a look at this, left hand side would be vision, right hand side would be natural language processing. It's like there's something which came first, on top of which something else was developed, which was improvement, and then something else. So this is how the incremental complexity keeps on happening. Okay. So if you are interested in the latest and flashy thing, which since 2022 is large language models, ChatGPT, stable diffusion, and all of these things. If you are interested in that, remember, things are built on top of each other. If you can copy the latest code which is ready-made available in as a ready-made by some open source program, it doesn't mean you understand it. Things are built on top of each other. To understand something well, you have to start from the beginning. So this thing allows us to kind of like group the entire timeline of deep learning innovation into three, four major chunks. The first one would be, since the field has begun, until 1990, it was almost in theoretical stage. So I didn't even count that only. It is very important, but it wasn't practical till then. It started since 1990. The first thing was we are simply being able to identify a digit as what digit it is. Identifying 0 as 0, 1 as 1, 2 as 2. That's all. And by 2022, we were able to identify objects. We were identifying digits in a very small image, 28 by 28 pixel. By 2012, we were able to identify 1,000 different kinds of images from huge number of images, and images were 224 pixel by 224, much bigger images. So we went from a small problem to a real life toy problem, and that is when entire data scientists prove that deep learning is not a dumb is not a gone subject. They proved that deep learning makes results possible. So everything, this becomes one section, and then on top of that, on top of object identification, we had, we identify the object. Let's identify where it is, how many, what is the depth, or maybe if this is the one object, how are the other objects like this going to look? That kind of like was built on top of the previous thing since 2012 to 2017. Okay. And then 2018, there was another research that is the third uh, thing which built on top of previous, and it was a completely new approach of looking at things, and just that has been continuing till now. So that corresponds to these problem statements: object identification and object segmentation and its depth estimation, 3D depth, or taking one image and identifying different image of the same category, things like this. Or if you want to take a look at the same thing in natural language processing, we have text classification, or we have identifying noun as noun, verb as verb. Oh, this is an important entity. What do I mean by entity? Uh, the planner which was launched today. So the planner here is a product which is being launched. So it's an entity. So that's what we call it. Keyword. Keyword would be a better word there. Key for it's important. So keyword identification, or maybe sentence similarity, or text summarization. So first group was simple, this text classification or keyword identification. The next improvement happened, it built on top of previous things, sentence similarities. And then 2018, we graduated to even more complicated problem. And then since 2022, LLMs are everywhere. But like Newton, like everywhere else, things are built on top of each other. If you want to take a learning path, you could take many different approaches. Preferably start with computer vision. So this I have put it as a 101 level, this as a 201 level, this as a 301 level, and this is like a very immediate one-to-one mapping of when it happened, right? So you could start with Vision 101 and then go to Natural Language Processing 101. Or you can start with Vision 101, go to Vision 201, and then go to 101 and 201 of NLP. Or you can start with NLP, but I wouldn't recommend that. If you are, too much rush to get to LLMs, you might be able to jump to 301 part, and you can, get some tiny bit work of 301 NLP you could do, but you will probably struggle quite a bit. You won't be able to do much. So my recommendation would be at least do 101 courses. This is what my recommendation would be. At least do these courses. Okay. So this is how the timeline look like. This is how it evolves. started from something in 2012 where data scientists proved to other computer vision people that deep learning works. Then everybody adopted it over time. And then in 2022, ChatGPT came, entire world realized how important and powerful it is, and then everyone kind of like started doing this, right? So this whole thing, 1990 to this thing, 101, 2012 to 2017, 201, 2017 to this thing, 301, and then the latest thing. The key innovation in 2017 was this transformer thing. Okay. Anyways, so this was the landscape of how we can kind of like decide how to learn and what is the order to learn things from. Now, after we learn, let's say how where do we apply that knowledge and where do we showcase that thing? Let's check that. So first thing, few important websites. You have to know these websites. You have spent some time, build accounts there, see how important they are, and kind of like understand. So starts with Kaggle. Okay. So Kaggle is where many data scientists solve problems all the time. No matter when, if you come, you will find there are problems which are real data science problems. They are running these problems with price, and not only such problems, there are discussions, then some code solutions to get started with. A lot of these things are available. So you can use this resource to actually build the most important thing, which is knowledge and understanding. So this is not important, the money you win or the rank you get, but the knowledge you build so that you can solve a even better or even complicated problem. That is what is important here. So Kaggle gives you these competitions, and most importantly, it is public where you can track your growth. So you see, it has whether you are competing, it has these ranks. Novice, contributor, expert, master, and grandmaster. So you see, contributor and novice, they're just still beginners. It doesn't count. Just create account, you get here. Expert is the beginning of your journey. This is expert compared to others. Okay, those who don't know anything in data science. For them, you will appear as expert. In reality, you're just a beginner in the domain of deep learning. Go further, master. Go further, grandmaster. Right? So this allows you to rank, chart your progress, do this growth, and this is very, very important because it gives you predictable way to measure growth. Okay. And it kind of like shows your activity in kind of like one place. This is very good. So you see here, my activity is I kind of like started sparingly since March, April, and it has been less. Even on the profile, I'm just a contributor. I haven't reached to a thing of even let alone expert, if not even higher. So working on it, and it can't be fake because the progress is visible here. Then what is next? Hugging Face. Hugging Face is amazing. Hugging Face is where entire world in the open source world in deep learning field, they kind of like put the data sets they have found, the models they have built, everything. It is extremely easy. If you want to take anything which is built here, someone has put in, you just have to navigate here. And in this easy to use format, you see everything. Let's say I want summarization to be deployed into my company and I want to use this. Facebook's ready-made one, which I'm sure they have spent a lot of time. If you want to do this, you just have to do this one. That's it. So Hugging Face makes these things to kind of like to take deep learning and apply it to things and build products out of it. It makes it a lot easier. And because of that, it is an amazing thing to kind of like know. There you can also track if you have put in some model, how many people have liked it, blah blah blah, all of those details. Just like Kaggle, you have its leaderboard. You kind of like can follow people depending on the quality of the thing you have done. It will get popular. You will get recognition, and with that recognition, you will know that what you have developed is good. It's all of these are places where we can refine our skills and improve them. Okay, so that's Hugging Face. Then we have Papers with Code. So Papers with Code is another excellent resource. I would recommend all of these resources should always be on top of your list, where no matter the data set, Okay, no matter the data set, you will find all of these details will be present here. And most importantly, pick the data set you want, and you will see how the improvement in that domain has happened over time. Okay, so here for this image classification since 2016, you see this is how the improvement is. If you can improve this accuracy in any different way compared to this, means you have done a breakthrough work here. You can achieve something in a different way. Maybe it is a breakthrough thing. So these problems, which are standard problems where all the researchers in the world are also competing, they are great for benchmarks, where you can use them and compare us against the entire world and see how and where we are doing. Okay, so these things like data sets, these things like problems, all of them you can find accordingly on its appropriate thing. If you want to see all the highest quality things, you just have to go to browse state of the art, browse the latest methods. So the same as we have in Hugging Face, on the left hand side, we have all the tasks which are supported by these AIs, right? The same thing we have here. It's all present. So for getting started after we have understanding, the things are a lot easier. So these websites make these things very easy. Okay, to get started with. And the last website is GitHub. So if you check my profile, I've started learning deep learning since October 2022. So this year, 2023, I've also started with this. In the beginning, I was doing a lot of lectures and I was focusing more on the mathematical part, but I made very slow progress. But since May, I started focusing on the programming, and as you can see, May, June, July, August, September, October, it's been going on, and this has consolidated a lot of my concepts a lot better than anything would have. Okay, so GitHub, these are all the places where you can apply stuff. And Kaggle is the best way, after spending time on GitHub, building my foundational skills. Now I'm ready to go to Hugging Face and Kaggle. And the same logic as we talked about here applies. Things are built on top of each other. You have to first learn to walk before you can attempt to run. You have to, know running before you can attempt to fly. Things like these, right? So it's the exact same thing. GitHub, practice coding, have build knowledge, blah blah blah. Then kind of like progressively you can get as close to the real world as possible. And once you have reached this place of Kaggle, Kaggle is almost real life problems. But in reality, real problems are even a bit more complicated than that, but it's a great proxy for them. So after you have done this, you are ready for the real world. Either get hired as a data scientist or you can build your own product because your knowledge is a valuable knowledge. You can add value, you can solve a problem better than anyone else can or anyone else has. Even if no one else, if even if everyone can solve a certain problem, but no one has, then it's still valuable, right? So this is the landscape of deep learning, and it allows me to inform how to kind of like learn and what are the orders, and accordingly I have grouped all the learning resources I had here, and this is my phase one learning. I've, I've been building my plan incrementally here. So build the landscape, understand the nature of the domain. It will definitely help you in your learning journey.